Okay, today we are going to start about isometric projection. Okay, so isometric projection, it is nothing but a projection of a solid or a combination of solid by projecting at an angle of 30 degree here. Okay, so you can see here we have 30-degree inclined lines. Using these lines we have to do the isometric projection. So in this isometric projection, so we see the first problem. A sphere of diameter 50 mm rests centrally on top of a cube of sides 50. So there are two solids given, one is sphere and one is cube. Cube of sides 50 and sphere of diameter 50. So you can see that sphere of diameter 50 rests centrally on a top of a cube. That means first we have to construct a cube here of dimension 50. Then after that we have to do the sphere. Okay. First I'm going to draw a reference line here. Okay. So reference line I'm drawing here. Okay, I'll take reference point here. So now we are using box method to construct the cube here. So cube of sides 50 mm. So I'm drawing box of 50 here. 5 box. 1, 2, 3, 4, 5. Okay. And similarly 1, 2, 3, 4, 5. And we have 1, 2, 3, 4, 5. Again 1, 2, 3, 4, 5. So box of 50 mm it is drawn. Now we know that in a cube we have vertical height also same thing, that is of 50 mm. 50 mm is again 5 box. 1 vertical height 1, 2, 3, 4, 5. Same thing here 1, 2, 3, 4, 5. Again 1, 2, 3, 4, 5. Same thing here 1, 2, 3, 4, 5. Okay. So now we have to join with the top face of the cube. Okay. I'm joining with the top face of the cube here. So you can see that we have constructed a cube. It is somewhat similar like a hexagon. Okay, so we have constructed a cube. Above it centrally we have to place a sphere of diameter 50. So centrally means first we are going to find out the center of the top face. Okay, center of the top face. Here it is 50 means exactly at 50 means 2.25. 25 means 2.5. We are going to mark. Okay. Okay, this is our center point. So from this center point, you see we have to construct a sphere of diameter 50. We have to consider a height of 25. Say 5, 10, 20. So 25 here, 15, 5 here, 15, 25. So this is what the center point. And here a sphere will be drawn with the actual scale. Okay, sphere is the only solid which will be drawn with the actual solid. Except a sphere, all the solids will be drawn with the isoscale. Only the sphere which will be drawn with the actual scale. Okay, remember it. So sphere will be drawn with the actual scale. So always remember it, because if we are going to incline sphere at whatever the angle it is, 30 degree, 40 degree or 50 degree, you will get the same circular shape only. So there is no change in the shape in case of your sphere. Okay, so remember it, sphere will be drawn with the actual scale. So this is our sphere and this is our cube. So you can show the angle. Here it is 30 degree and here also 30 degree. Okay, sphere will be drawn with the actual scale. So remember it. So this completes the problem. You see the second problem in isometric projection. So you can see the question here in two solids given. One is hemisphere. Okay, hemisphere of 40 mm diameter. Hemisphere means it is nothing but the half part of the sphere supported coaxially on the vertex of a cone. So the second solid given it is cone. So for that cone they have given base diameter 60 and axis length 50. So that means we have to construct the cone first, then after that we have to construct the hemisphere. Hemisphere means half part of the sphere. Okay, now flat circular face of the hemisphere facing upside. Okay, so first we are going to construct the cone here. So for the cone the base diameter given 60. Okay, so first we are going to take the reference line here. Okay, reference line. So here you can see that base diameter 60 means we have to do the 6 boxes here. 1 2 3 4 5 6. Again here 1 2 3 4 5 6. Again 1 2 3 4 5 6. So we have to construct the 6 boxes on either side. The 6 box it is constructed. Now you see that the base part of the cone it is which is given with the diameter 60 means it is in circle. Okay, so when the circle it is constructed in iso it will become ellipse. Okay, it will become ellipse. So how to construct the ellipse I will show. So herein to construct an ellipse we have to go for 4 arc by center method. Okay, first I am going to mark the middle point of all the edges. If it is 60 means exactly you can mark at 30 here. Okay, 30. Now I am drawing the lines here like this, arrow lines you can draw here. Okay, so like this 4 lines you have to draw. Then after that we have to use compass here. Okay, using compass by measuring this length. Okay, I have to draw first arc. Okay, then again from this point, so measuring this length, so measuring this like this. And then third point we have to measure this from this point using compass. Third arc, next fourth, measuring again this distance. Okay, so we have constructed an ellipse. Okay, so this is what the base diameter, when it is constructed in ellipse it becomes a it is a base part of the cone 60 mm diameter circle converted into ellipse in the iso. Now we have to find out the center. We have an axis length, right? So center of the box here, like this. This is the center of the box. From this we have to consider a axis length of 50, that is 5 boxes. 1 2 3 4 5. So draw an vertical height of here 60. Now we have to draw an connecting tangentially. You have to connect like this tangentially to make sure the surface of the cone has to touch like this. So this completes the cone problem. Now we have to place the hemisphere, which is having a diameter of 40. So 40 means again we have to construct a 4 box here. 1 2 3. That is 40 mm box means 4 box. 1 2 3 4. 1 2 3 4. 1 2 3 4. So it is done. Okay, 4 boxes. Again you can see that hemisphere means it is the half part of the sphere. So it is in circular. So when it is constructed, it is the circular, means when it is constructed in iso, it will become ellipse. Okay. So again I am marking the middle points here, in front of the box. Okay. Now using compass we have to cut the arcs here. This length. Okay. Again from this point, so measuring this length. Okay, so it is done. So now again we find out the center of the box here. Okay, from this center point, so how to construct the lower part here from this point to here. Okay, exactly here we are going to take and then join it like this. Okay, so this completes the problem. Here you can see this is our 30°. So this it is cone and this is hemisphere. You can see that this flat circular face, it is facing upside. So this completes the problem. So you can like the video, subscribe and share it.